All right, so here we are with our third example of an integral by u substitution. Again, a definite integral, and again from Salicilla and Etkin. This time we are looking at the integral from 0 to 1 over 2 of cosine cubed of pi x times sine of pi x dx. And again, we notice that this thing has a factor of sine, and we know that the derivative of cosine is negative sine, and so this is suggesting to us that we could probably use u substitution here, because the cosine of pi x will become the u. There's going to be a chain rule thing going on with the pi, but we'll be able to adjust for that. And again, we're just going to kind of go with it and see what happens and do the adjustments if we need to. So setting u equal to cosine of, that's a strange cos, not C alpha s, cosine of pi x, we get du equal to, now it's going to be negative pi sine of pi x dx. And so this is the thing, this guy right here is the one that we need to be matching. We need to kind of create this in here by making appropriate adjustments. And so again, next line of the argument is going to be rewriting this thing now as negative 1 over pi integral from 0 to 1 over 2 of cosine cubed of pi x times now negative pi sine of pi x dx. And again, by putting in this correction factor of negative 1 over pi at the front here, and I kind of skipped a step and pulled it out. The more of these we do, I'm going to kind of skip more steps because you guys get the idea of what's going on. That allowed me to work the pi in here and match this du. Now here I have a du, and I can make this substitution putting the u in for the cosine cubed. All I'm going to have to do is adjust the boundaries, the bounds of integration, and we'll see how to do that in the next step. And again, the pen is going away on me. Right, this is negative 1 over pi, now integral of u cubed du, but I have to think about what is happening to the bounds of integration. Again, my bounds are not going to be, I'm not looking at, again, the a and b bounds. I'm now, since I've done the u substitution, I'm looking at u of a and u of b as the bounds of integration. And here, u is cosine of pi x, so that means I have to plug in a, which is 0, and b, which is 1 over 2, into cosine of pi x, so to get my new bounds of integration. So what happens when I do that? Well, I get cosine of pi times 0, that's just cosine of 0, which is, of course, 1, and when I plug in 1 over 2, I get cosine of pi over 2, which is 0. So my new bounds of integration, maybe in a different color to really emphasize this, my new bounds of integration are going to be 1 and 0. And this is looking a little bit strange because usually I'm used to the lower number being at the bottom and the bigger number being at the top, but I can just fix this by exchanging the bounds of integration and multiplying by a negative. And I should probably do a video on that as well. I'll do a separate video on integral properties. So if this looks strange to you, just kind of believe me for now until the next video, or to the video on this is up. The next one is going to be more examples, but just trust me that I can do this. I can write this as 1 over pi integral from 0 to 1 of u cubed du now. I can multiply by a negative sign and switch the bounds of integration. And this is 1 over pi times, should maybe make this a little bit nicer, pi there, that's kind of better, u to the power of 4 over 4, evaluated from 0 to 1, and this should come out to be 1 over 4 pi. And that's it. I will see you guys in the next video, which should be, I hesitate to say harder, but more interesting.